Okay, so this is for the advanced 8th grade math, which is the algebra 8th grade. So this is going to be for Isaac and Jury. So I know that Jury, you had already done lesson 9.1. So there was just a few things that I had told you that I was mistaken about. So I'll just point that out in a few of these. Isaac, you haven't done this at all, so this will be very beneficial for you. So first of all, we're trying to find patterns and write expressions for them. So here we have some patterns. You got 2, 4, and 6. They want you to draw out those figures. So if you can see, the pattern is that they're just adding 2 more each time. So you add 2 more to each drawing. Let's see if I can get this picture to be this right. I don't know if it helps, but you got your drawings there. And then if you go down here, they want you to make a table. We're going to make a table where we got the figure numbers versus the number of pebbles. And I already made that out. So you should have it looking like this. Okay, so where I have, like, for figure 1, it's 2. For figure 2, it's 4. For figure 3, it's 6, and so on. So if you can tell, you are adding 2 each time. So that's what we call the constant difference. Okay. Number 3 asks, extend the pattern to determine how many pebbles are in the 10th figure. So if you can imagine adding 2 each time, that means that you're going to be on the 10th one. If I extend it out to the 10th one, it would actually be 20. And what you can do here, instead of having to count it out every time, is you can take the rule that every time you have a constant difference, you're always going to take that constant difference and multiply it times your figure number. So for example, you could actually see here that the pattern also is that if you multiply 2 times 2, it's 4. 2 times 3 is 6. 2 times 4 is 8. Okay, so anytime you have a constant difference, you're going to put that constant difference in front of your variable, or your term that's right here. So this times your constant difference will always give you this. Okay, so always put your constant difference in front of your variable, and then you can have an expression that will always give you the right number for your output. Oh, wait, sorry, constant difference. Okay, then let's go to the next one. It says, describe the patterns you observe in the pebble drawing and the table in words. The pebbles are twice that of the figure number. How many pebbles are in the 53rd figure? Explain your reasoning. Well, we can again multiply 53 times 2, and that's going to give us 106. So here we have, again, 2 is my constant difference, and then I'm multiplying it times my n. So remember, I don't have to put multiplication here, but it's assumed that if you have a number next to a letter, that's multiplication. So I'm saying here that every time that you want to find the number of pebbles, all you need to do is multiply 2 times your figure number. Okay? So then let's go to the next page. Write a, hold on, let me focus this. Okay. Oh, it's just not wanting to focus. Okay. So this is where I misspoke with Jury about the answer to this one. It says write a similar numeric. Okay. To get this to focus. Okay, so on 7 it says write a similar numeric expression using the number 7 for the number of pebbles in the number of pebbles in the 7th figure. So I had thought that they were talking about 7 being the number of pebbles, but that's not what they were talking about. They just wanted you to simply write out what we just were saying, 2 times 7. So they just want to see that you know how to use that expression that we just came up with to get an answer. So 7 times 2 would be accurate for what you needed to put on this answer. Oh my goodness. I'm trying to get this to focus and it just does not want to. Oh my goodness. It's going to take like 5 minutes to just focus this thing. Okay, so I'm still trying to mess with this document camera. So I'm still trying to focus it. It will not do it. It will not focus at all. Oh, there we go. Finally. Okay, so after 5 minutes of trying to focus the thing, let's go to number 8. So on number 8, it says let n represent the figure number. So this is exactly what I was talking about. So the n is going to be your figure number, and we have an expression to use to figure out what the pebbles would be. That would be 2n. What value would you substitute for 3n to determine the number of pebbles in the third figure? You would just use 3. So I'm substituting 3 for n, and I'm going to get 6 pebbles. So n would be 3. So again, when I was talking with Jury about this, I thought they were talking about something more complicated, but they're just asking how you would plug that in just to get the number of pebbles for the third figure. On C, I already done that up here, so I just put an arrow down here to actually plug it in and check it. I did that. Okay, use your expression to determine the number of pebbles in the 100th figure. So again, I would just put 100 times 2 equals 200 pebbles. Check your understanding. We got some figures here. How many small squares are in each figure? We can put that up here. So this would be, for figure 1, you would have 4. For figure 2, you would have 6. For figure 3, you would have 8. Draw the 4th, 5th, and 6th figures to determine the number of small squares in each figure. So we would draw this out. 1, 2, 3, 4. Actually, I'll let you guys draw that out. All you're doing is you're just adding a square, making a Z pattern. So, I can just do this. So for the next one, I've got, let's see. So that's that one, and then I'm just going to add on one more block on each end. So that would be the 4th. And then for the 5th, again, I would just rewrite this. One, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, and then 2, 4, and then another pair, and then see. So that would be the 5th one. So we added another one on top and on bottom. And then the 6th one, I'll do the same thing. So 1, 2, 3. I have 6 of these. And then I would add one more on each side. So this would be, should be 10 and 12 and 14. Draw a table. So we have X, Y here. So for figure 1, we're going to say that's X. And for Y, we're going to say that's the pebbles. So when my X is 1, I have 4. When my X is 2, I have 6. 3, I have 8. 4, I have 10. 5, I have 5, I have 12. And 6, I have 14. So if you can tell, you have a common difference here, or a constant difference of 2 again. Describing words, the pattern you see in the square pattern in the table increases by 2 each time. How many squares would be in the 10th figure? Explain your reasoning. So again, we already wrote that out. So in the 4th figure, well, let's just go back and see if we can write an expression, right? So if I have a constant difference of 2, that means my, sort of my rule is that I'm going to put the constant difference here next to my variable n, and that should be able to give me what I want every time. So if I plug in 10, well, somewhat. So if I plug in 10, that's going to give me, well, here, this is different. Hold on. This one is different because you actually have a starting value. So for this one, we actually have to figure out what we have when there's nothing here. So let's see, 2 times, hold on one second. this is different, and I'll tell you why in a second, but on this one, we're going to okay, so let's try to do it the way that we did it before, okay? So if we do it the way we did it before, we would do 2 times n, but if you notice, if I do that for 10, that's going to give me 20, and that's not what I have here, or that's not what my answer would be. If I expand this out, right, if I get 7, and then I do 8, 9, 10, that would give me 14, 16, 18, 20, 22. So it's not going to be 20. So you ask yourself, why is that? Well, that's because we didn't start out with 0. So we have to figure out what our starting value is. So on the one from before, the one from before, if I go back to 0, that's going to give me, if I go back to 0 and I subtract 2 to figure out what that value is, if I take 2 and I subtract 2, that's going to give me 0. So I had no starting value here. So this was all that I needed. I just needed to have 2 times the variable. But for this one, I actually do have a starting value. Because you can notice here, 1 times 2 is not going to give me 2. So there's some starting value here that I need to figure out. So that's close to the answer, but not the correct answer. So what we're going to do is I'm going to rewrite the table here. So for your future reference, you always need to check to see if your starting value is 0 or if there is some starting value. So if I have 1, 4, 2, 6, and 3, 8, and I have a constant difference of 2, I can go back and see what my y is going to be when x is 0. When x is 0, if I subtract 2 from 4, that's going to give me 2. Or sorry, yeah, it's going to give me 2 as an actual value. So I subtract 2 from 4, that gives me 2. So if I actually made my table to where it included a 0, right, that 0 would have a value of 2 here. So my starting value is 2. Sorry, excuse me. So that means that I add that to my expression. So I'm going to have the 2n still, but I'm going to have to add 2 because that's what I started with. Okay, so this is my expression for this problem. So if I'm asked how many squares in the 10th figure, you could count it out, or you could make your little expression and you'd have 2 times 10 plus 2, which would give me 22, just like I have up here. Okay? So constant difference for your expression goes in front of the variable, and then you have to go back and figure out what y is when x is 0 to see if you have a starting value. If you do have a starting value, you're going to have to add that to your expression. Okay? So let's go to the next page. That was 9-1, first page. So if we go to your next page, I believe that's 107. Yes, that's going to be 107. So you have another pebble arrangement, and you got to draw out the 4th and 5th and 6th figures. So you're just adding a dot on each side, or a pebble on each side of the L shape. You can do a table here. This was the figure number, this was the number of pebbles. So I wrote that in. For figure 1 I had 1, for figure 2 I had 3, and so on and so forth. And I put in what the difference is. So the difference, if you looked from 1 to 3, it was 2. From 3 to 5, it was 2. From 5 to 7, it's 2. From 7 to 9, it's 2. And if I go up to 0 on here, I'm also going to have a difference of 2. So if I do 1 minus 2, that's going to give me negative 1. So I actually do have a starting value on this one as well, and it would be negative 1. Because if it's a constant difference, that means it's also a constant difference going backwards. Right? So if I add 2 here, then I would subtract 2 from here to get what I want for my 0. Okay, so constant difference of 2, and then I expanded it more here. So you're just adding 2 each time. On C it says describe the pattern. We have a constant difference of 2. We subtracted the consecutive terms. We got the difference. We already did that. 16 asks you, how does the constant difference in the new column relate to the pattern you observed? It's the same. The difference is the pattern. The constant difference is your pattern. Okay, so then we go to 108. It's the back. They have another table here where they expanded out their reasoning here with how they're getting the numbers. Oh, sorry, here. You can see this. I don't really agree with how they're teaching you this because it's kind of teaching you what this is without the starting value. But if you wanted to go that route, if you go with what they start with 1. So you would have 1, and then for the next one you have 2 times 0, because you're just adding 2 more. So then each time you're just adding 2 right to the 1. So you start out with 1, but that's not really the starting value, because your starting value should be with 0. But on this one they're starting with 1, and they just add 2 each time, and that does work, but it kind of messes with how you would write your expression. It says write the number of pebbles in the 4th and 5th figure using repeated addition of the constant difference. We did that here, so I wrote the repeated addition here. So you just keep on adding 2, and you would get, so write the number of pebbles. So this would be, 7. This would be 5. This would be 9. Okay, and it said let n represent the figure number. Use n to represent an expression that could be used to determine the number of pebbles in figure n. If you're doing repeated addition, should I even show you this? If you're doing repeated addition, if you notice here, this is just, I don't think I'm even going to show you this. I'm just going to show you how we've been doing it. So this is going to be, this would be 3. And this, of course, is 2. So let's figure out what our 0 would be. So our 0, so my constant difference is 2 still. So if I go back, like we said, this would be negative 1, because if I'm subtracting 2, right? If I'm subtracting 2 from 1, that's going to give me negative 1. Sorry, can't see that. Negative 1. So I'm not going to write this. That makes sense. Okay, So on this one, your expression would be 2n, and then my starting value is minus 1. And then for C, same thing. I'm going to erase this. What value would you substitute for n to determine the number of petals in the third figure? I would do 2 times 3. So it would be 3. N would be 3. Plus 1. That would give me 7. And then erase this. On this one, check to see that the expression from part A is correct by evaluating it when n is 5. So we're going to do 2 times 5 minus 1. So that would give me 9. So when n is 5, I should have 9, and that's exactly what I have up here. Okay, use an expression to determine the number of pebbles in the 100th figure. So we would do, again, 2, the constant difference, times the variable, and then our starting value, which was negative 1. So if I put in 100 here, I'm going to have 200 minus 1, which is going to give me 199 when n is 100. Okay, and I think that's it for lesson 9.1. I think the rest is just your own practice, so you should be able to do that on your own now. And I'll give you the next stuff tomorrow. Thanks, guys. Bye.